So I'm going to go over a general factoring strategy. Like this is a good way to generally approach when you need to factor a polynomial. So the first thing you're going to want to do is see if you can factor out the greatest common factor. Okay? And then I want you to look at the number of terms in the polynomial. So right, if there are two terms, you might have a difference of 2 squares or a sum or difference of 2 cubes. Remember, the sum and difference of 2 cubes are the only rules you need to memorize. For everything else, we can find the factors of AC that add up to B and factor by grouping. If there are 3 terms, your trinomial could be a perfect square, or you can find the factoring, they call that trial and error, that's find AC that add up to B. If there are 4 or more terms, try factoring by grouping. And then once you have factored once, you need to verify that each of those factors is factored completely. And if you want to check your answer by multiplying, this is something I always recommend, especially on exams. If you finish with enough time, go back and check all of your work. So here's some examples I'd like you to do on your own. I can go ahead and get started on a couple. So for this first one, we're really just going to be factoring out the greatest common factor, which is 9. So that gives me 9 times p plus 5. This next one, we're also going to be factoring out the greatest common factor. That's going to be, the greatest common factor is 4xy, so I'm left with 2xy plus 1. Same thing here, greatest common factor of a plus b, so I've got 5x minus y times a plus b. These are perfect cubes, so you're going to need to use your cube rules, your cubic rules. This is a difference of perfect squares, okay? And here we have a sum of perfect squares. But there's not a rule, right, for the sum of perfect squares. So this is actually prime, and it cannot be factored any further. Here's a few more examples. Always remember to pull out the greatest common factor. Here, I know in class, when you guys were looking over the worksheet for our review chapter, I got a couple questions about completing the square. And let's go over that. So if I have x squared plus bx, which is a binomial, if I add my middle term divided by 2 and then squared, it's going to make it so that I can factor as a perfect square. So let me show you how that works. So if I have x squared plus 8x, I'm going to add 8 divided by 2 squared. Well, 8 divided by 2 is 4. 4 squared is 16. So I have x squared plus 8x plus 16. So let me show you how this is going to factor to a perfect square. So I'm just going to have to factor it. What are the factors of AC, in this case, that add up to b? Well, the factors of 16 that add up to 8 are going to be 4 times 4, or because it's 4 plus 4 is 8. So I have x squared plus 4x plus 4x. Remember, I'm just pulling that middle term apart, plus 16. If I factor by grouping, collect my greatest common factors, have my remaining binomial. This is x plus 4 squared. It becomes a perfect square. This is always going to hold true, even if I have a negative b. So let me show you how we would do that. So if I have x squared minus 14x, I'm going to add negative 14 divided by 2 squared. Well, negative 14 divided by 2 is negative 7. Negative 7 squared is going to be a positive 49. So this will factor into the perfect square x plus 7 squared. And if you don't believe me, you can factor it yourself. when will we need to complete the square? Well, we want to complete the square because it allows us to get a perfectly factoring trinomial. This is really useful sometimes when we come across prime trinomials that we can't factor. So I'll show you how we'll use this later on in the course.